I'll come to your house and kick your seating area. That is Sushanth.
Hi.
Hi. And that is Raghav. I do not know why is he in here.
मैं क्या करूं फिर जॉब छोड़ दूं?
I'm a spectator. I just watch whatever you guys do.
So Sushanth is here. He is our video editor. He's been editing a lot of our videos, and in fact, the recent ones are his and Pavitran's video editing skills that's coming out. And so Sushanth here has no clue about electronics. So we are going to learn about two sensors, like I mentioned before. One is the most used and underrated sensor. This is it. Can you guess what is this?
Is that a speaker or something?
It is actually a speaker. I'll explain you why. Okay, what do you think it is, Raghav?
Wally's head.
And you have any idea what this is?
That's a filter for tea. It kind of looks like that.
This one will make you look like that, but it's too expensive to be a filter for tea, man. So this is an ultrasonic sensor. I'll explain this first, but this is the most used sensor in electronics projects and in robotics actually, and in real life too. This one is not that used. There are very specific use cases for this. This is known as a rain gauge sensor. Okay, so do you have a car?
Yeah.
Is there a car? The car is having parking assistance.
It has sensors, like not a camera but sensor.
How does it like
when I
reverse
the
what
gear
happens?
and go back, shows me the lines like how far the object is to the car.
I can do the same with this. So the sensor used in that particular scenario is this. I mean, this is a company that builds sensors, and if you have noticed your car back, you must have seen this kind of a thing. So this is the sensor that detects objects in front of it and tells you how far is that thing away from that sensor. So this is nothing but an ultrasonic sensor. There are some details you need to see. So let's have a picture on. This is literally the sensor that I have on my side. One is a transmitter and another is a receiver. Now let's get into the basics. So have you ever been to a hilly area?
Yeah.
So when you speak loud into emptiness, don't you hear yourself back again?
Yeah, I do.
Yeah, let's go into one of that scenario. So you're standing near a cliff. I don't advise this, but okay, you're standing near a cliff. I don't know what's that line in the middle, but let's.
That's a pole I'm leaning to.
That's the wrong pole you're leaning to, bro. So this is the mountain cliff, you can see. Sound has various properties. When medium changes, sound speed changes. If you were in front of me and you would have air as a medium, the sound wave would travel through the air. If it's going through air, the speed of sound is generally taken as 340 meters per second. When you are transmitting your voice, so the wave is going like this, whatever, just ignore my drawing, and then hitting the mountain cliff or whatever, and then coming back to you. If you just say hi and then just start your stopwatch and then you hear back when you hear hi again for the first time, you literally have the time that sound wave took to go to the mountain cliff, hit it and come back to you. So now the thing is, the distance between you and the mountain cliff is constant in this entire scenario. You don't move. The distance is constant and the speed of sound is constant. It is not changing because the medium is not changing in the middle, right?
Yeah.
So there are two constants. Now do you remember speed is equals to distance per unit time? So distance is equals to s into t, speed into time. Here is a catch. The time it took is twice the time it would take to just come from your mouth and hit the mountain, right? It took 2 times the time that it would take just to hit the mountain. So we divide the time by 2. That's the distance between you and the mountain. This thing works at a frequency range of 40 kilohertz. So this is a wave, but the wave doesn't stop there, right? It still continues like this. So if you have a line here that you're observing from, imagine in a second these 3 waves, because we have 3 waves here, like you see. From this line, in a second, these 3 passed in a second. So what would you say? What's the frequency at which the wave is passing through the line, Sushanth?
For this it is 3.
Yes, that's right. Now that sensor deals at 40,000 hertz. Now, interestingly, 20,000 hertz is the maximum which we can hear. Okay, so we are dealing with frequencies beyond 20,000. But this is in 40,000 range, so you can't hear it. This little buddy here operates in that frequency. So it basically passes 40,000 waves in a second. This little pocket. Now let's go into the operation of it. So the computer sends this thing a signal of positive voltage. In general, that is 5 volts for 10 microseconds. What does that signify? What is the computer trying to say to this sensor is that, dude, now you have to start working, start emitting. I want to know how far the object is in front of you. That's what the computer is trying to say. As soon as it receives that signal, it emits 8 40,000 kilohertz signals, 8 of those in a burst, right, like this. That 8 is like the high from your mouth. Now that goes, and let's say this camera is my object. This is the trigger, so this goes from here and then it touches that, and then it receives it back. When it receives it back, these 8 are received. If you see, when it receives it back, the receiver side turns on due to the voltage of that received signal.
Like now, from the moment it sends the last 8th signal, it starts sending voltage, and the moment it receives, it will stop sending that.
As soon as the wave hits the receiver, the counter is stopped, the timer is stopped. This amount of time is then sent to the microcontroller MC. And Sushanth, my friend, that's how you detect how far that particular car or the object is there in front of this sensor. This is known as a rain gauge sensor. So Sushanth, you must be aware of the rainfall stuff, right? On the newspaper clippings you do get every day that how much millimeter of rain has happened yesterday, how much is going to happen tomorrow. So that certain millimeters of rainfall is detected. Now my question to you is, do you know how is it done? You get one of these and then put up a funnel on top of it, collect rainfall, and see how much of this has filled, and what's the millimeter or inches of height is that column. So literally that is how much rainfall has happened in your area approximately. This was a technique used for a lot of years until new technology came, which is a tipping bucket. Now how does this work? It's the same. You have a funnel on top of the collection point. The funnel collects the rainfall, the rain droplets go down there. The bucket is like this, it's like a triangle. So the bucket is like this. So the water droplets fall on one of these buckets all the time, and that bucket fills up to a certain level that basically increases the weight of the side of that side of the bucket, and then due to the weight this bucket comes down and the other comes up, and when it comes down it drains out this water, and this side gets it fills up. So every time that happens there is a tip. Every tip you multiply with the amount of that calibrated weight. With that you get total amount of water collected. But the problem is, this design is a mechanical design. You see, this thing is moving. It's like a saddle. So this thing moves and there are moving parts. If there are moving parts, there is a huge guarantee that this won't work. To solve this problem, these kind of sensors are made. Moving here, it works on infrared radiation, and this is way more accurate than that. Basically, this is the inner view of this same sensor that we're looking. This is of this shape for a certain reason, dude. One, the droplets falling on this will just fall off of it, so it doesn't stagnate water on top of it. Two, it is because of total internal reflection. You see the computer. You can see that computer on this. Well, that's not. That's not total internal reflection. That's what I was trying to say. Sorry. The thing is, you have windows, right, with proper glass. From outside the building, you cannot see the inside sometimes. In certain angles, it is not going into the medium. It's coming out of the medium. It's bouncing off of the medium. That is total internal refraction. That is what's happening here. Because it's infrared, it is also having the properties of light. That dome structure is made in a way that every infrared beam that's coming out of the transmitter is refracted inside it and then received by receiver. Okay. So based on the amount of intensity the receiver is receiving, how many drops have accumulated or fallen on top of this dome? Based on the number of drops and the size of droplets, it will give you how much a millimeter of rain has fallen on top of it. Yeah, so there are two settings in this thing. So one is if you set it up to this setting 0.01 millimeter, then the amount of rainfall that's detected, if it is reaching 0.01 millimeter, then this sensor sends one pulse like this to the microcontroller.
A few moments later.
Raghav went for dinner. So he'll eat for an hour.
One eternity later.
Yeah.
What was it?
Okay, let's say we have put it in a higher place where human disturbance won't be there. What if a bird comes and disturbs it?
Yeah, so that those kind of things can happen, but this sensor has certain signals for that. Okay, so when you turn it on, actually when you provide power to this, if the lens is clean,
Okay.
this green light will blink thrice. You can configure it in a way that whenever there is something accumulated on top of it, if there is some obstacle on top of it, let's say a dirt, or it will blink lesser than thrice or maybe more than that. So
Where-
what car do you have actually?
Tata Tigor,
Tata Tigor. Is the wiper automatic on it?
not auto. Where they
Yeah, there are some vehicle companies in Europe, I think it's there in India as well, some that have these installed under their windshield. So behind the rear view mirror, you will see a kind of a lens coming out. This is less accurate, this is way more accurate. This is used for rain sensing. This is used for just to detect what's the rain amount of rain. These are the two sensors. So yeah, I hope you liked the explanation. Hope you understood stuff from this.